with Scott from CGTech. Now, you're participants in the Kyocera SGS Lunch and Learn event, but I've been learning a load of stuff about CGTech, VERICUT and Force. But first of all, I want to cover off VERICUT. I'm thinking safety first.
So VERICUT in its core form, yes, it's all about getting the part right, off the machine, correct first time.
Okay. So you've got a virtual machine tool and it's doing it all for you?
Yeah, so we cut what we call a VERICUT machine configuration, or your digital twin in effect. And that's what it's about, eliminate, improve out, and making sure there's no element of collision, so the program's safe and good to go before you take the CNC code to the machine.
With utmost confidence?
With utmost confidence, yes.
Now, you probably saw, I was sitting in the back of Scott's presentation about Force, and the light bulbs were coming on, they really were, in terms of what it does. It was really engaging presentation. But, well, not but, three things that came out of that: attack, defense, and chip size optimization. So tell me what that means.
So there's two. The theme of today I wanted to go with really was to try and make it simpler for the audience to understand.
You clearly did, because I learned a lot of stuff.
Good. So the theme I went with was defense and attack, or attack and defense, whichever way you want to look at it. So first of all is your attack, and that's about optimum chip thickness. We want to get the chip thickness throughout the process constant and even. So that's where we can push our chip thickness up, because we're not achieving an optimum chip thickness.
And this can all be seen in visual form in graphs?
Yeah, so basically VERICUT Force maps the process from A to B, from the start of the toolpath right to the end, and we can see that in graph form. We can see any defects in the process, and that's what we call our defense. So if we've got a defect or a spike, that's where we want to defend and reduce feed rate. But mostly we want to increase the chip thickness to be constant and level by varying the feed rates in the CNC program.
Okay. Also, in terms, you mentioned Force as well, though. That has an effect as well?
There's two calculations. The product's called VERICUT Force, but there's effectively two calculations. There's a force calculation in newtons. It sounds complicated. It's really not. And a chip thickness calculation. And they're our two parameters we want to adjust. We want to attack the chip thickness, but we want to defend with a force.
In terms of information you need to provide the system, very simple?
Very little. To make Force work or switch it on for analysation, all you need in turning is two parameters, and that's rake angle and material. Obviously milling is a little bit more. You need the diameter of the tool, the number of teeth, the material, helix angle and rake angle. And these are known.
Yeah, so every engineer will have that anyway.
Yeah. These are known values.
So again, it was a great presentation. What sort of benefits, improvements can I expect from this system?
Broadly speaking, from what we've seen in the UK, I'm going to say range between 8 to 15% in aluminium. It's very broad. It could be more. I'm not going to say it's going to be much less. In hard metals, anything 15% upwards. I've seen personally gain to 28%. With the part we did today here, that was a 20% cycle time reduction.
Okay, so we're at the Kyocera SGS, their famous lunch and learn event. So why are you involved in that?
They're an incredibly easy partner to work with. The tooling's very good. We operate in very, very similar markets. So a lot of the aerospace business, Kyocera SGS, are very well established, as are CGTech, VERICUT, very well established. So yeah, they're a great partner to work with.
Okay, so really impressive stuff. Application specific, of course. So if you do want to test out, get in contact with the guys at CGTech.